This is the first of what will be a considerable sequence of videos on bottom-up parsing. The first thing to know is that bottom-up parsing is more general than deterministic top-down parsing. So recall we talked about recursive descent, which is a completely general parsing algorithm but requires backtracking. And now we're focused on deterministic techniques, and we talked about LL1 or predictive parsing last time, and now we're going to shift gears and talk about bottom-up parsing. And it turns out that even though bottom-up parsing is more general, it's just as efficient, and it uses all of the ideas that we learned in top-down parsing. And in fact, bottom-up parsing is the preferred method that's used in most of the parser generator tools. So one good thing about bottom-up parsers is they don't need left-factored grammars, so we can revert to the natural grammar for our example, and natural here is in quotes because we still have to encode the precedence of plus and times. So bottom-up parsers aren't going to deal with ambiguous grammars. And let's just, as an example, consider how a bottom-up parser would work on the following typical input string. So the first thing to know about bottom-up parsing is that it reduces, what we call reduces a string to the start symbol by inverting productions, by running productions backwards. So here's an example. On the left-hand side is the sequence of states of the string, and on the right-hand side are the productions that were used. And the thing to observe, let's just look at the very first step, is that we began with the entire string. We began with the string of terminals, and we picked some of those terminals, in this case just one, this particular int right here, and we ran a production backwards. We replaced the int here by the left side of the production. We matched the right side of the production int, and we replaced it by the left side. So int went backwards here to t. And then in the next step, we took int times t, this substring of the string that we're working on, and we replace it by the left-hand side of this production. Int times t was replaced by t. And so on. In each step here, we're matching some portion of the string, and I'm underlining the portion that's being replaced at each step. And we're running, and that matches the right-hand side of some production, and then we're replacing that substring by the left-hand side. And finally, this entire string here is replaced by e, and we wind up at the start symbol. So we began with an input string. This is our input string up here, our input string of tokens, and we end with the start symbol down here. And if you read the moves in this direction, if you start at the bottom and read towards the top, well, these are just productions. And in fact, this whole thing is a derivation. This is just a normal derivation going from bottom to top. But in this direction, when we run it backwards, beginning with the string towards the start symbol, we call these reductions. And I haven't told you exactly how we decided what reductions to do, and you might wonder, well, how did I know to do this particular sequence of reductions? Well, here's another interesting property of bottom-up parsing. So if you read the productions backwards, they trace a rightmost derivation. So if we begin here with e, so remember, the parser is actually going in this direction. So this is the direction of parsing here. But now we're going to look at the steps the parser took in reverse, and we're going to see that it was, in fact, a rightmost derivation. So here e went to t plus e. Well, e was the only non-terminal. But then e here is the one that's expanded. It's the rightmost non-terminal. And then this t is expanded. It's also the rightmost non-terminal to get int. And now this t is the rightmost non-terminal. It's expanded to get int times t. And then this is the only and rightmost non-terminal. And so we wind up with the whole input string int times int plus int. And this leads us to the first important fact about bottom-up parsing, which is that a bottom-up parser traces a rightmost derivation in reverse. All right, so if you're ever having trouble with bottom-up parsing, it's always helpful to go back to this basic fact. A bottom-up parser traces a rightmost derivation, but it does so in reverse by using reductions instead of productions. So here's the series of reductions again shown on the left, and here is the parse tree that's constructed from those reductions. And this is actually, I think, a very helpful picture if we animate it. to see the sequence of steps and to see what a bottom-up parser is really doing. So here we begin with the input string over here, and we show the same input string here. And now we're going to just walk through the sequence of steps that the bottom-up parser takes, a series of reductions, and show how it builds an entire parse tree. And the basic idea is that at each step we're performing a reduction. And remember, when we do a reduction, we replace the children of the right-hand side of some production by its left-hand side. And just like when we were doing top-down parsing, we would make the right-hand side the children of the left-hand side. Well, we'll do the same thing here. So here's the child in the input, and then we make t its parent. And now you can see what's going to happen. A top-down parser begins with the start symbol and produces the tree incrementally by expanding some non-terminal at the frontier, at a current leaf of the partially constructed parse tree. The bottom-up parser is going to begin with all the leaves of the eventual parse tree, the entire input, and it's going to build little trees on top of those, and it's going to be pasting together all of the subtrees that it's put together so far to build the complete tree. Let's walk a few more steps and see how that happens. So in the next step, we go from int times t to t, and so int times and the subtree rooted at the other t become children of this non-terminal t. And you can see we've taken these three subtrees here and pasted them together into a larger tree. So as we go through the parse, bigger and bigger portions of the original input are going to be pasted together into larger and larger trees. And the next reduction takes the int at the far end of the input and reduces it to t. And that gets reduced to e. And then at the very end, the three remaining subtrees are all pasted together into one parse tree for the whole thing with the start symbol as the root. So to summarize, a bottom-up parser traces out a rightmost derivation in reverse, and it builds a parse tree by combining small parse trees into larger ones. It proceeds bottom-up. Instead of expanding out from the start symbol top-down, it builds from the leaves of the tree up towards the root.